I'm going to go through activity 10B, number 10 of the ESA book. So if we look at the question, you can see PQ represents a uniform beam of mass 2 kg. So uniform means the mass will act from the center. So if I put a finger here, I can balance this beam. There was nothing on it. So and the object of mass 4 kgs is placed so that it's 0.5 meters from Q, and the beam is 2 meters long. So they're asking is how much does the force on Q exceeds force on B. So this tells us that we need to work out the forces on P and Q. The first thing I will do is I will draw a diagram. So if I move on to the paper. So I have my uniform beam. So the weight of the beam will act at the center, and we know the beam is 2 kgs, so it'll be 20 newtons, because the weight is mass times acceleration due to gravity. Then we have two of these which create a reaction force upwards. So I'm going to call this force P and force Q. Then we have a mass of 4 kgs, so 4 times 10 will give us 40 newtons as the weight from that mass. So I'm going to pick a rotational axis. So I'm going to pick this one. So if I find moment from that point, that means that I don't have to worry about this force P. So my torque at clockwise will be, this is 1 meter, the whole thing is 2 meters, 1.5, 0.5 I mean, so this should be 1.5 meters. So clockwise, so that's that direction there. So there will be 20 newtons times 1 meter plus 1.5 meters times 40 newtons. So that's 20 newton meters plus 60 newton meters. So that gives us 80 newton meters. So this is the clockwise torque. So the counterclockwise torque will be 2 meters times the force Q. So it'll be 2 times Q. Since the system is in equilibrium, because this is not stationary, it's not accelerating, so we can have 80 newton meters equal to 2Q. So counterclockwise equal to clockwise. Oops, it should be the other way around. But so the Q will be 40 newtons. So that's the force, 40 newtons acting upwards. So now we will find moment from here. So we make our rotational point from here. So this will get rid of Q. The reason is because we already know Q and we want to figure out what P is. That's the reason for picking that point. So again, we do the same procedure as before. So we find our torque clockwise. It will be 2 meters times P. And torque counterclockwise will be 0.5 meters times 40 and 1 meter times 20 meters. So that works out to be 20 Newton meters plus 20 Newton. So it's 40 Newton meters. Since it's in equilibrium, we can make torque clockwise equal to torque counterclockwise. So we have 2P is equal to 40 Newton meters. So P becomes 20 newtons. So now we know the force P is 20, force Q is 40. So the question asks is how much does force on Q exceeds P? So it'll be, for question A, it'll be force Q minus force P. So that becomes 40 newtons minus 20 newtons. So that's 20. So that's our answer for A. Then the part B asks to calculate the total clockwise torque around moment P. And so we know now the Q, we worked it out to be 40 newtons. So it's 40 newtons upwards. So it'll be 2 times 40. So that'll be the anti-clockwise torque. So torque anti-clockwise, so I call it counterclockwise because so it'll be 2 times the Q that we worked out. So it'll be 2 meters. So it's 80 Newton meters.